Okay, so we're going to go over another example of the horizontal curve, the circular curve elements. Now in this example, I've actually got a tangent coming in and then a tangent going out. And sometimes you'll hear it described as that. And in this one, the tangent coming in is given in as a bearing, and the tangent going out is given as a bearing. So the tangent going in is north 56 degrees, 48 minutes, 20 seconds east. So what you want to know is the PI station is 6 plus 26.57, and the tangent going out is a bearing of north 40 degrees, 10 minutes, and 20 seconds east. Okay, so we know that the radius here is 100 feet. Let's start with our tangent coming in and refresh ourselves on bearings. If north is straight up and I'm going northeast, that means this angle right here is 56, 48, 20. On this one, where that intersecting point is, if north is straight up, it's saying that it's going out from this point at 40, 10, 20, okay? Now, to be able to get this angle in between, what I'm going to have to do is I'm going to have to do some subtraction. Okay, so when somebody gives you a bearing and two bearings, then what to get this intersection angle from this blue line to this line here is I need to subtract the 56, this whole, minus this one here, the 40. Okay. So what I need to do now is I'm going to calculate my PC, my PT, my tangent lengths, my length of curve, my degree of curve, the long chord, the external and middle ordinate distances for this intersection, this horizontal curve. So I write down my equations that I'm going to use again. So again, these are just the abbreviations that we use in the equations. Now, to get the intersection angle, we take the tangent in and the tangent out and subtract them. Now, you can't always do that on everything, depending on which direction you're traveling on your bearings. So, we're going to use the length of curve is 2 pi r I over 360. It's in degrees. Our tangent is equal to the radius times tangent, the intersection angle, divided by 2. The PC station is the PI minus the tangent. The long chord is going to be 2r sine of I2. The degree of curvature is going to be 100 times I over L. And remember, I is in degrees and L is basically the 100 feet. The PT is the PC station plus the length. The M is R, your radius, times 1 minus cosine I over 2. And E is the external distance, R times 1 over cosine I over 2 minus 1. So let's get started. Tangent in and tangent out. So I've got 56, 48, 20, 56 degrees, 48 minutes, 20 seconds, minus 40 degrees, 10 minutes, 20 seconds. So this angle in here, this I angle here, and this I angle here is 16 degrees, 38 minutes, and 0 seconds. So I plug it in, the I into my equation to figure out L. L is 1,000, because that's the radius length, times 2 pi r. Now, see the 2 pi? I can take that 2 and cancel out the 360. That's why it's over 180, just to let you know. Okay? So the length of this arc here, is 290 feet, 290.31 feet. Now the degree of curve, notice that is in degree. You take your intersecting angle divided by the length and multiply it by 100. So the degree of curvature is 5 degrees, 43 minutes, and 46 seconds. Now that is based on a 100-foot station. So it's called the length of the station is based on 100 feet. So the T, the tangent, is equal to the radius times the tangent of the intersection angle divided by 2. Plug in my equation and I get the tangent length. This distance from here to here is 146.18 feet. So now I'm going to calculate my stations up here. So PC is equal to the PI, 6 plus 26.57 minus the tangent, and PT is the PC plus the length of the curve. So 626.57 minus the T, the tangent length that we figured out here, and I get a PC station of 4 plus 80.39 here, and then I add the 290.31 feet to get the PT here. So that station at the end is 7 plus 70.70. So I can't just add the tangent length to get to that point. Okay, they're going to be close. Now, here's the equations for my long chord, my middle ordinate, and my external distance. All I need is my radiuses. My radius, my intersection angle, times 2. The long chord is 2 times radius sine of I over 2. The middle ordinate is r times 1 minus cosine I over 2. And E is radius times 1 over cosine I, it should be an I, not a 1, over 2 minus 1. Okay? So just plug these in, make sure you've got the concept. Understanding where these values come from and what they're actually describing. All right? That's it for this. The homework is posted online. If you have any questions on how to do the circular curve calculations for a simple curve, just please send me a message.